Bonus project for AP Calculus by Mallory Henderson. How to find the derivative. First, we're going to talk about how we find the derivative and how you can use different formulas for finding the derivative. The limit used to define the slope of a tangent line is also used to define one of the two fundamental operations of calculus, differentiation. Be sure you see that the derivative of a function of x is also a function of x. This new function gives the slope of the tangent line to the graph of f at the point x, f of x, provided that the graph has a tangent line at this point. The process of finding the derivative of a function is called differentiation. A function is differentiable at x if its derivative exists at x and is differentiable on an open interval ab if it is differentiable at every point in the interval. You can find the derivative by the limit process to find the slope at a point, finding it of a function, a graph of a sharp turn, a graph with a vertical tangent line, using the constant rule, using the power rule, finding the slope of a graph, finding an equation of a tangent line, using the constant multiple rule, using parentheses when differentiating, using the sum and difference rules, involving sines and cosines, finding average velocity of a falling object to find velocity, the product rule, the quotient rule, finding the acceleration due to gravity, the chain rule, implicit differentiation, and related rates. Example number 1, we're going to see how to find the derivative with the function y equals parentheses 4x minus 1 to the third power. Example number 1, part 2. You're going to solve and distribute the 3 to the front and drop the degree 1 less than the original degree. Find the derivative of what is inside parentheses and multiply it outside of the equation, which is using the chain rule. So we move the 3 to the front. Then you have parentheses 4x minus 1, drop the degree to 2, and multiply what is inside of the parentheses to find the derivative, which would be 4 to the outside. Example number 1, part 3. Multiply the 3 times the 4 and keep it in front of the function. Therefore, our final answer is 12, parentheses 4x minus 1 squared. Second thing we're going to do is how to find the limit. The notion of a limit is fundamental to the study of calculus. The following brief descriptions of two classic problems in calculus, the tangent line problem and the area problem, should give you some idea of the way limits are used in calculus. Except for cases involving a vertical tangent line, the problem of finding the tangent line at a point P is equivalent to finding the slope of the tangent line at P. You can approximate the slope by using a line through the point of tangent C and a second point on the curve, as shown in figure 1.2a. Such a line is called a secant line. If P of C of P of C is a point of tangent C at Q, parentheses C plus delta x, F, parentheses C plus delta x, is a second point on the graph of f, the slope of the secant line through these 2 points can be found using pre-calculus. As point Q approaches point P, the slopes of the secant lines approach the slope of the tangent line, as shown in figure 1.2b. When such a limiting position exists, the slope of the tangent line is said to be the limit of the slopes of the secant lines. Much more will be shown about this on the next slide. Example number 2, part 1. We're going to find the limit as x approaches 1 of x minus 2 divided by x squared plus x minus 6. Example number 2, part 2. First, try to plug in that number for x. If the limit is equal to 0, then you have to factor it out. So here, we're going to try to plug in 1 for x and see if it does not equal 0. But if it does, you're going to have to try to solve the limit another way. So now we have limit as x approaches 1 of 1 minus 2 divided by 1 squared plus 1 minus 6, substituting 1 in for x. Example number 2, part 3. Solve the function and see if plugging in works. So here we have the limit as x approaches 1 of 1 plus 2 over 1 squared plus 1 minus 6. 1 minus 2 is negative 1, and 1 squared plus 1 minus 6 is negative 4, which equals to be 1 over 4, which means that we have found the limit without having to use 0. So substitution of plugging in 1 did work. Conclusion. Calculus is the mathematics of change. For instance, calculus is the mathematics of velocities, accelerations, tangent lines, slopes, areas, volumes, arc lengths, centroids, curvatures, and a variety of other concepts that have enabled scientists, engineers, and economists to model real-life situations. One way to answer the question, what is calculus, is to say that calculus is a limit machine that involves 3 stages. The first stage is pre-calculus mathematics, such as the slope of a line or the area of a rectangle. The second stage is the limit process, and the third stage is a new calculus formulation, such as a derivative or integral.